This is Numbers with Nicole. We're going to do two models where we're going to go backwards with the arc length. We're going to solve for the radius first. So we're going to be given the arc length, and then we're going to have to find some of the other pieces. So we're just working backwards. Again, in the lesson, we did this using a proportion, so solving for one of the other pieces is pretty easy. So find a central angle measures 143.24 degrees. Way to be really specific there. That's an estimate. So 143.24. And intercepts an arc that is 20 feet in length. So this arc length is 20 feet. And we want to know what is the diameter of the circle. So since this is arc length, right? Feet is length. We know we're talking about circumference and not area. So we're going to do part of the circle compared to the total circle. And in terms of degrees, we have 143.24 is the part of the circumference and the central angle. And then 360 is the total number of degrees. So since we're solving for diameter, I'm going to use the circumference formula pi times d. And d, or diameter, is what we are looking for to get by itself. Now, the arc length that they gave us was 20 feet. That's the part of the circumference, or the part of that length around the circle, so that goes up top. So I'm going to cross multiply. That's how we solve our proportions. They need to be equal when we reduce them down. And so we're going to have 143.24 times pi times d equals 360 times 20. We want the diameter by itself, so I'm going to divide by 143.24 times pi, and I'm going to put that in parentheses because when I put it in my calculator, I'm going to put it in parentheses. Remember, your calculator is going to do order of operations, so if you don't put it in parentheses, it's only going to divide them by the 143.24 or the pi, depending on which one you put in first. So 360 times 20 divided by 143.24 times pi, enter. And so that's going to leave me with a diameter to the nearest hole would be 16 feet. Right. In this example, we're going to just find the angle. Again, we're going to use the proportion method, and we're going to be given the arc length. And in this example, I also gave us the arc length in the exact form, which is 2 pi. So we know from here to here is 2 pi, a length, and we know we're dealing with circumference of a circle because it's a length. It doesn't say area. If it said area, then we would be dealing with area of a sector. So we want to find the measure of angle B. We have a radius of 10. So we're going to set up our part of a circle to our whole circle. Our part of our circle is angle B. That's what we're looking for. And the full number of degrees in a circle is 360. Our part of our circumference that we're given is 2 pi. And we have a radius. So our whole circumference, C equals 2 pi r, would be 2 times pi times 10, so 20 pi. And I'm going to cancel those pi's out, because that's extra buttons I don't need to push in my calculator. So I have angle B over 360 equals 2 over 20. You could reduce this fraction down. I'm using a calculator anyway, so I don't really need to do that. So I'm going to have 2 times 360 divided by 20 times 360 divided by 20, and we get 36 degrees for angle B.